GraphsinR. So today we'll be understanding how do you work on graphs in R. Basically three different types of graph objects. So the base R graph object, and then so basically talk about graph devices in R. So there is a base graph device, and then there is one advanced form which is lattice, and then if you go beyond that there is ggplot. Each of them have their own advantages, and we'll try to understand how these work. Right, to roughly start with, let's look at the broad indexes which we are going to cover. So the objectives for this session would be a brief introduction into graphs, line plots, bar charts, pie charts, histograms and density plots, scatter plots, 3D and parallel coordinates. This would be the core essence of this whole module, right? Okay, so first of all, why do we need graphs? We need graphs because it tells a story. It tells us something which a normal person can make out very easily. Assume you're walking on the roadside, right, and all of a sudden you want to cross the road, right, and there's a crossing, right. Now how would you understand that this is the place where you have to cross? There is a zebra marked over there, right. There would be something which shows as pedestrian crossing, pedestrian bridge. There would be something which says as a image that allow the pedestrians to cross the road first. Now all of these are typically depicted in the form of a image. Why? Because an image doesn't have a language, right? An image can be understood by a person who reads English, Hindi, Marathi or anything, and that is why we prefer depicting analysis and outputs basically in graphs, right? So this is what we are going to do. Now a unique case of visual information. Now graphs predominantly have been in existence since the 16th century, right? One such case which is depicted on your screen is about a cholera outbreak which happened in London, right? Now it was very difficult specifically to identify what was the cause of this outbreak, but when the same thing was depicted on a plot, on basically something which is called as a geographical image, if you overlay as to where the maximum cases of cholera is being identified, that is where people understood that this is happening because of contamination in the water tank. So most of the cases are being reported close to an area which is very close to a water tank, wherein you are seeing that there is infestation of some kind of parasite, right? Now if you were to do this kind of analysis in a data frame or in a table, you wouldn't really understand, because there won't be something like a long and a lat data, so you won't be able to identify where is it happening. And that is why visual information is very much important when you want to actually analyze lots of data in a very short frame of time. So our first graph in R will be very simple graph. So we'll first create a vector, and I'm just saying 1, 2, 3, 4. So it would be C sorry, I'm using X as an object, so C, or else I can even say 1, 2, 5, right? And I can also say Y, when I can use an allocation sign and specify that I want C1, 5, 3, 2, 0, and I just create it, and I say plot an X versus a Y, right? And this is how the data shows up in your R, right? So this is your base R graphic device, right? Now a couple of examples are shown on your screen as an exercise which you can do basis your availability of time. So we'll go into the next part, wherein we'll try to see how would you visualize an inbuilt data set like the empty cards which we had seen previously. And I'm going to say attach empty cards. So we have brought this data into the console, right? And we're just going to, let's have a look at the names, okay? And I'm saying empty cards, right? So these are the various variables available. There is MPG, that is miles per gallon, there is cylinder, there is displacement, horsepower, D ratio, weight, Qsec, VS, AM, gear and carb. Now I'm going to do the plot of two of these variables, say weight with MPG, that is weight versus miles per gallon, and this is how the data shows up, right? It's basically a scatter plot, right? So an X versus Y. So on the y-axis you can see miles per gallon, and on the x-axis you can see the weight, right? This is how the plot seems. If you try to relate with this data, it shows that there is a negative relationship of miles per gallon. So as the weight increases, right, so as you can see, as this is increasing, the miles per gallon is reducing, right? Now we don't specifically understand what this data is, but we're just trying to understand basis the graph. Now you can do something like an AB line, which means draw a line from point A to point B, and inside that I'm using an LM, that means a linear model. Now we haven't got into what linear modeling is, so we are not getting into that part, but it's basically something like what you use as a trend line in Excel, right? And if you just draw this, it's basically drawing a linear line through the data, and you can say that yes, there is a negative relationship between MPG and weight. So as weight is increasing, MPG is reducing. That's what you can see, right? Now you can also put something like a title, because a graph would be meaningless if you don't have a title. So I'm putting a title, so you can use the function title, and you can say regression of MPG, that is miles per gallon, on weight. Now you can specify this in capital or small as you prefer. Now one thing you would be observing is that we are using this graph device in R as if it's a frame or it's a portrait, right? So how does an artist paint? So an artist would first paint the base coat, then he will put the next layer by using some charcoal, he will make some sketch, and then he will keep on adding some colors, light colors first and dark colors to top up. In the same way, you're going to use the base graph object in R on the similar notion, right? So first you did the plot, then you did the AB line on that, and then you added the title. So you're doing one thing at a time, and it is getting added to the same chart again and again, and finally you're making a picture, which makes sense, right? So we'll move ahead from here, and before that we'll just detach the empty cars data set so as to not waste our RAM. Now you could use something like, if you want to work on the graph and you want to just save this in a PDF form, so one option is that you can just go over here and say export and save as an image, right? So it will be saved as a JPEG file or a bitmap image, or else you can use as save as PDF. But for those who typically are writing codes which act as a middleware between a front end and a back end, in that case usually a user doesn't have the access to actually use R directly, right? So it will be some set of codes which is running in the black screen, or what you would say in the command prompt in the background. So in that case you might want these things to be automated also, so you can do the PDF conversion manually also, right? So you can say PDF something like this, and you can say my graph dot PDF, right? So what you have done is you have just saved the graph in a current working directory, right? And you want to see so this is the file, right? So this is how you will save it, right? Now you can actually just click over here and you can say more, and you can say move to something. Now I'm doing two things at one time, so it is giving me an error. So I'm just going to close this. You can copy, move, and do anything you want, right? Now I can attach again the empty cars package data, right? And I'll say plot again the weight versus MPG, and then what we are seeing over here is that it's not getting plotted because it's actually been written in the file itself. And I'm saying LM and MPG tilde, that's a separator, weight, and the title, just to make a difference, I'm saying title is equal to new regression of MPG on weight, right? Just to see the difference. Detach t cars, and I'm saying dev dot of this. It shut down the specific graph object. You might not want to do this right now because you're currently using it, and then you can just, so again you can just create some data here so that you can work on it. Dose C and say 20 comma 30 comma 40 comma 45 comma 60, right? And then you're saying drug A, allocation sign C 16 comma 20 comma 27 40 and a 60 again and drug B, allocation sign C 15 18 25 31 and 40. Yeah. Now what we can do is we can do a plot. So I'm saying plot dose versus drug A, and type is equal to B indicates that you want to type both the points and the line, right? So you have options like type is equal to L is a specification that plot the graph as a line. Okay, so all the data will be connected with lines. If you say with P, it means points. So we'll have a look at B first. Redo this. Okay, I guess we'll have to restart R because the graph device is off. Okay, so I'm just going to start it again. And I'm just going to go into history and just select the last few options. Okay, so this is how it's working, right? And if I just say instead of B, if I say an L, it will just do the line graph. If I do this as a P, it will just show the points, right? So you could use these alternatively as per your requirement so that you can see the graph basis your requirement.